Hello class. Today we're going to look at solving radical equations. So our radical equations, we've been working with these for this unit and the last unit. And pretty much all our radical equations are anything that has that big radical. The index can change, but any radical. And equations, when we have that equal sign, and we're trying to figure out what x is. Now, something that is interesting with our radical equations is we're potentially going to have solutions that don't work. We're going to find them, but when we solve, they might not actually work like we'd like to. We're going to call the extraneous, see if I can spell it right, nope, our extraneous solutions. We'll see a couple examples of these today, but our extraneous solutions is we're potentially going to have solutions that, while we find them when we solve the problem, we will find these solutions, but they are not actually solutions. Now what we can do is we can plug our solutions back in to check. So we have to plug our solutions into the original function. Function to check. Alright. Original function to check. But we'll see some more of that later today. But first of all, let's think about ways that we will be able to solve these. So let's look at our simple example. Say we have the square root of x is equal to 4. Now, I need to figure out some value of x. When I take the square root of it, I get 4. Well, if you remember back from our last unit, we can actually convert this radical into a rational exponent. So for us, our index on the outside is a 2. So the bottom of our fraction is going to be a 2. And the top of our fraction is going to be the power of the x. We have a power of 1 here. So the top of our power is, or top of our fraction is going to be a 1. The reason that this is helpful for us is our goal is to get x to the first power, not x to the 1/2 power. But to cancel out 1/2, I could multiply this by 2, right? So what we can do is we're going to take everything on this side and square it. But it's an equation, so if I do it to one side, I have to do it to the other side. So we'll take everything on the other side of the equation and square it as well. Now, if I have a power raised to a power, that lets us multiply our powers together. So I have 1/2 times 2 is equal to 4 squared, which is 16. Okay, 1/2 times 2 gives us x to the first power. So x to the first power is our 16, and that's our solution. Now, we can kind of skip this in-between step here. What we're really going to do is we're just going to square both sides of the equation, but the reason that it's canceling out our radical is because we can turn it into a fraction in the exponent. But from here on out, we're not really going to be rewriting this because we can skip those steps. And checking for extraneous solutions, if I plug 16 back in, square root of 16 is equal to 4, and we get 4 is equal to 4. can erase that real quick. We get 4 is equal to 4, which is what we wanted. It's a true statement, so our solution is good. So this isn't a real solution. It's not extraneous. Okay? Let's see how we can apply this idea. So let's say I have this equation here. 3x minus 5 is equal to 4. Well, first things first, let's isolate this 3x, or square root of 3x. Let's get this by itself. So if I want to get this by itself, I need to remove this 5. And to get rid of it, we're currently subtracting 5. The opposite of subtracting 5 is adding 5. So we add 5 to both sides. We'll get our square root of 3x stays the same. 4 negative 5 plus 5 cancels. 4 plus 5 gives us 9. Now, what we just saw is if I want to get rid of a square root, what I can do is square both sides of my equation. My square and my square root are going to cancel out, so we're left with 3x is equal to 9 squared. 9 times 9 gives us 81. Solving for x, trying to get rid of that 3 now. 3 is currently multiplying with x, so we'll do the opposite, which is division. 3 divided by 3 are cancel. We need to do it to both sides of the equation. So we get 81 divided by 3. And if we want to, always do your long division if you ever get stuck. Also, feel free, if you have access to a calculator, that could also be helpful. But we should get 27. Okay. Alright. So, let's look at another example. But these solving or simplifying our radicals are actually going to be fairly similar to our normal solving equations. We're just adding in getting rid of the radicals. I realize this is a little blurry. This is a 3 right here. Let me write that in there for you. Okay, so I want to get this cubic root by itself so that I can cube both sides to cancel out that cube. So let's try to get rid of the 2. Currently the 2 is multiplying with the radical. Excuse me. So we'll do the opposite, multiplying by 2, which is dividing by 2. Divide by 2 from both sides. And we'll get our cubic root of 2x plus 5 is equal to 18 divided by 2 gives us 9. Now, when we were getting rid of a square root, we raised it to the second power. We squared both sides. When I'm getting rid of a cubic root, it's going to be a similar idea, but since this is a 3 instead of a 2, what I'm going to do is I'm going to cube both sides. Okay? So my radical is going to cancel out. We're going to be left with 2x plus 5 is equal to, and we have 9 to the third power. It's going to be our 9 times 9 times 9. So our 9 times 9 gives us 81. If we multiply that by 9 again, we'll get 729. But always feel free, use a calculator if you have one available to you. Okay. But this operation right here, that's what's new today. We're figuring out how to cancel out those radicals so that we can solve for x. Alright, so let's try to get this x by itself. I need to get rid of positive 5. I do that by subtracting 5 from both sides. 5 minus 5 cancels out and we get nothing. write that down. Bring our 2x down. 729 minus 5 will give us 724. Currently, the 2 and the x are multiplying together. So the opposite of multiplication is division. Divide 2 from both sides. So we'll get x is equal to our 724 divided by 2. Just grab a calculator, unless you want to do some long division. We get 362. Okay? Now, if I wanted to check this for extraneous solutions, what we're going to have to do is we're going to have to plug this, our solution, back into the original equation. So, be a little bit of a pain here. Let me see if I can. This whole. I don't know why it's not letting me get a new page. Or extend it. Okay, so we're gonna do. We have our 2 cubic root of 2x plus 5 is equal to 18. And I want to check for extraneous solutions for x is equal to 362. So what we're going to do, we'll take our 362 and we're going to plug it in for x. So on the outside we still have 2 cubic root of, and we get 2 times 362 plus 5. All we're doing is replacing that x value. It's still equal to 18. Okay, let's simplify this. So we have 2 times 362 gives us 724. 5 is equal to 18. Add our 5 to it. 724 plus 5 will give us our 729. It's equal to 18. Take the cubic root of 729. So we get 2 times cubic root of 729 is 9. So 2 times 9 is 18. We get a true statement, so we're good. This is a solution. Okay. Now, let's look at another one. I want you guys to give this a go. I'll give you a couple seconds here to pause the video, and then we'll look at the answer and go over it together. Okay, hopefully you got a chance to give it a go. And all we had to do, divide both sides by 3. 12 divided by 3 gives us 4. Cube both sides to get rid of our radical. So we get x plus 2 is equal to 64. Subtract 2 from both sides to get 62. Take a couple seconds to check and make sure this is not an extraneous solution. Give you a couple seconds to pause the video, and then we'll go over it together. Okay, hopefully you had a second to give this a go. If I plug my 62 back in, inside combined, 62 plus 2 is 64. Cubic root of 64 gives us 4. 3 times 4 gives us 12. So our solution is a solution. Alright. Okay. So, is this... okay. So, I'm going to pause the video, give you guys a second. I want you to try this out and check and see if your answer is a solution. Give you a couple seconds and we'll go over it together. Okay. Hopefully you guys had a chance to give this a go. Solving for x, subtract 4 from both sides. We get negative 12. Divide by 3 to cancel out the 3. We get negative 4. Square both sides. We have 6 minus x is equal to 16. Subtract 6 from both sides. We get 10. And to get rid of the negative, we just move it to the other side. So we have x is equal to negative 10. If we were to check it, plugging our negative 10 back in, minus negative 10 is the same thing as plus 10. So we get 16. Square root of 16 is 4. So 3 times 4 is 12. 12 plus 4 is 16. Okay. And now, does 16 equal to negative 8? No. This is where we find a solution through solving for x, but we check, we find that it is not a solution, so it's an extraneous solution. Usually this is going to happen when we're squaring that negative there, but we do always want to check to make sure that our solutions are solutions. Alright, now let's look at 2 more examples for today. We'll do one together, and then I'll have you try one. So, notice how we have multiple square root of x's here. But let's think about if there's a way that we can combine them. Are these like terms? Is the radical exactly the same? Well, yeah, they're both just the square root of x. So if I wanted to combine these together so that I can solve for it, we can do that. So what I need to do is either move this x to that side or this to that side. I'm going to move this one over to the right. So opposite of plus square root of x is going to be our minus square root of x to move it over. So we'll have minus square root of x on both sides. Square root of x minus square root of x cancels out, goes away. 4 square root of x minus square root of x, well, 4 minus 1 gives us 3 square root of x. Okay, and everything else stays the same. Solve to get this 3 square root of x by itself. I need to move the 15 over. So let me add 15 to both sides. 6 plus 15 is going to give us 21. Negative 15 plus 15 is going to cancel. We still have our square root of 3x. Okay. I want to get the square root of x by itself, so I need to get rid of this 3. Currently they're multiplying, so I'm going to divide both sides by 3. 3 divided by 3 cancels out. 21 divided by 3 gives us 7. So we have 7 is equal to square root of x. To cancel out my radical here, I can square both sides. 7 squared is 7 times 7, which gives us 49. It's equal to my square root and square cancel out, so we get 49 is equal to x. Now, let's check and see if this is an extraneous solution. Let's take our solution, plug it back into the equation. So we get 6 plus square root of, our answer was 49, is equal to 4 times the square root of 49 minus 15. Just plugging it back in. Simplify. Square root of 49 is 7. So we have 6 plus 7. 4 times square root of 49, once again, is 7 minus 15. 6 plus 7 is 13. 4 times 7 gives us 28. We still have that minus 15. So we have 13 is equal to 28 minus 15 will give us 13. So 13, 13, that's true. So this is a solution. We're good to go. Okay. And last one. I want you guys to take a second to try this. combine your like terms, and solve it out. Okay, give a second to pause, and okay. Hopefully you had enough time to give this a go. We combine our like terms to get 2 cubic root of 4x plus 6. Subtract the 6 from both sides. Gives us the 4 here. Divide both sides by 2. Gives us the 2. Take cube both sides. 2 cubed gives us 8. Radical cancels out with the cube. Divide both sides by 4 to get x is equal to 2. Check to see if it's a real solution by plugging the 2 back into the original equation. Plug 2 in for x, so we have 4 times 2 on the inside of the radical now. That's what's changing. Okay, simplify here. 4 times 2, both insides, will give us 8 and 8. Cubic root of 8 gives us 2. Simplify down further. Do our multiplication. 7 times 2 is 14. 5 times 2 is negative 10. Combine our terms. 14 minus 10 is 4. And then 4 plus 6 gives us 10. This is a true statement, so this is a real solution. Alright, I hope you guys have a great rest of your night.